Welcome to Brain Vision.
So in this problem, the final amount of ice is less than the initial mass of water. So water remains, and the final temperature is 0 degrees Celsius. The ice added warms to 0 degrees Celsius, and heat comes out of the water and converts it to ice. Conservation of energy tells us that Qi plus Qw must equal to 0, where Qi is the heat flow for the ice that is added, and Qw is the heat flow for the water that freezes. So from here it follows that Mi is the mass of ice added and Nw is the mass of water that freezes. So we also know then that Mi plus Mw is the increase in the mass after, so that's 0.328 kgs. And we wish to find Mi, the mass of ice that is added to the styrofoam box. So if we go with Qi plus Qw is equal to 0, this means that the mass of the ice times the specific heat capacity, MiCi, times delta T, the change in temperature of the ice, which is 15 Celsius degrees, plus the heat flow for the water that freezes, which is the mass of the water that freezes times the latent heat of fusion for water, is equal to 0. And we also know that the mass of the water Nw is simply 0.328 minus the mass of the ice. So we can eliminate the mass of the water and introduce the mass of the ice. So that is MiCi times 15 plus, and now we'll eliminate Mw, minus 0.328 plus the mass of ice Mi times the latent heat of fusion Lf is equal to 0. So as you can see, we have one equation with one unknown, since we know the specific heat capacity for ice and we know the latent heat of fusion for water, or water becoming ice. So if we rearrange this equation, we can solve for Mi as required. Mi, we rearrange the equation, is 0.328, that's kgs, into the latent heat of fusion, Lf, over specific heat capacity for ice multiplied by 15 Celsius degrees plus the latent heat of fusion, Lf. And since these values are all known, we can then go and calculate this mass of ice that was added to the styrofoam container. So that's 0.328 kgs into the latent heat of fusion from water to ice of 334 times 10 to the 3 joules per kg, all over the heat capacity for ice. Specific heat capacity is 2100 joules per kg Kelvin, multiplied by delta T, which is 15 Kelvin. Remember, 15 Kelvin is the same as 15 Celsius degrees, plus again the latent heat of fusion, 334 times 10 to the 3 joules per kg. So now that we've substituted our values in, we complete the calculation, we get that Mi is equal to 0.3 kgs. So what this means is 0.3 kgs of ice was added